Welcome back, everybody. Today we are working on chapter 7, confidence interval. The problems on this chapter are based on the concept that we have learned in the previous chapter, that is chapter 6. Example, find Z alpha over 2, or we also say Z critical, for a 92% confidence interval. Let's find out what is this. So let's begin here. So whenever we are talking about the Z value, we have the standard normal distribution. That's why the scores are Z scores. That means along the x-axis, you have your Z scores, okay? And your distribution is a standard normal distribution. Now, when we say 92% confidence interval, that is our middle 92%. Here, this middle region is the 92%. This is your 92%, 0.92. This area is the 92% of the total. So when we talk about the confidence interval, we are talking about the middle percentage, whatever is given in that confidence interval. So here it is middle 92%. So this is 92%. This interval from here to here is 92%. And the value, the Z score, which is over here and here, is Z alpha over 2. So this value here is Z alpha over 2. That means this one here is negative Z alpha over 2, because the values to the left of this mean, which is here in the middle, is negative, and to the right is positive. So this is positive Z alpha over 2, and this is negative Z alpha over 2. Now what we are asked to do is, we are asked to find the value of Z alpha over 2. Now what you know is, in order to find the Z alpha over 2, which is here, you need the area to the left of Z alpha over 2. You always need that. So let's find the area to the left of Z alpha over 2. That's what we need. Area to the left of Z alpha over 2 is equal to, if you want to find the area to the left, please look at this figure carefully. When you go from here, here's Z alpha over 2, from here up to here, the area is 0.92. We know that, 0.92. But we also have this area on the tail. From here, we have to come all the way up to the end. So this area is missing. So we need to know what that area is. We need this area. We need that area. But by symmetry, what we know is this area and this one here, they are equal. These two areas are equal. But if you look at it very carefully, this is 92%. So out of 100%, when you subtract this 92%, 8% area is remaining. So this area on the right and this area on the left, when you add them together, it is 8%. But this 8% is divided equally into two parts. So this is 4% area and this is 4% area. So this is 0.04 or 4%. And this is also 0.04. Make sure you label this. So this area is 0.004. So meaning of that is the area to the left of Z alpha over 2 is, from here to here, it's 92% or 0.92 plus 0.04. Plus 0.04. Now by adding those two values, you will get 0.96, or 96% of the area is to the left of Z alpha over 2. The reason we do this is because we want to find this Z alpha over 2. In order to find the Z alpha over 2, you need the area to the left of that. So once we have the area, now we can use our calculator. And you know that in your calculator, we have Z alpha over 2, make sure you write this, Z alpha over 2 is equal to inverse normal, inverse normal. This is the command that you use in your TI-84 calculator. Inverse normal, then you'll write the area to the left of that Z-score. So from here to the tail, we got 0.96, 0.96. Then you need the mean because we are talking about the Z-score. So this is the standard normal distribution. So mean is 0 and the standard deviation is 1. So what we are going to do is we are going to use our TI-84 calculator and get this result. Now what you'll do is in TI-84 calculator, you go to second, then vars, and then number 3. So here you'll put your area, which is 0.96 in our case, 0.96. Your mean is 0, standard deviation is 1. This is area to the left. If you have left, you select left. Otherwise, you don't have to do anything. You just go to paste. You just go down and paste that to the main screen and hit enter. You should get the result. And I got 1.7507. So this result is 1.7507. So that is the Z alpha over 2. Example, find Z alpha over 2 for 99% confidence interval. So in this example, we have to find the Z alpha over 2 or Z critical, which is the same thing, for 99% confidence interval. So when I say 99% confidence interval, the area in the middle, C is equal to 0.99. So area in the middle is 99% or 0.99. So we are going to represent that in our normal distribution here. Make sure you draw and label it like this. Along the x-axis, you have the z-score. This is standard normal distribution. Standard normal distribution. Because we are talking about the z-score. So this area in the middle is 99%, 0.99. So you can label this area that is 99%. That is your C, or area in the middle, for 99% confidence interval. And the values which are here, this one and this one, this is Z alpha over 2, and on the other side is negative Z alpha over 2. Because the value to the right of the mean, which is here in the middle, is positive. So positive Z alpha over 2. And the value which is on the left of the mean in the middle is negative. So it is negative Z alpha over 2. Now you can also find the area on the tail. This area, which is on the left tail, and the area on the right tail, they are equal by symmetry, because the normal curve is symmetrical about the mean. So this area in the middle is the 99%. So this area plus this area on the tail is 1% area. That 1% area is divided into two parts. So 1 divided by 2 is 0.5% or 0.5%. So this is 0.5%, this is 0.5%. When you divide 0.5% by 100 to write in decimal, it is 0.005. 0.005. And this is 0.005 because that is 0.5% or 0.5%. So 0.5 divided by 100. When you change the percentage to decimal, you divide by 100. 0.5 divided by 100 is 0.005. So those are the area on the tail. The reason we need this area is because to find this one, Z alpha over 2, we need the entire area on the left of that. So now you can write that area. area to the left, area to the left of z alpha over 2, area to the left of z alpha over 2 is equal to, you can see here, from here up to here, the area is 0.99. When you are adding this area here, which is plus 0.005. You can add this using calculator. 0.99 plus 0.005. That is 0.995. Because the area to the left of z alpha over 2 is 99.5% area. That's why it is 0.995. Now, in order to find this z alpha over 2, we use the inverse normal command in our calculator. So we do this. Now, z alpha over 2 is equal to inverse normal. Then we write the area to the left of z alpha over 2, which is 0.995. 0.995 is the area. The mean for this distribution, for a standard normal distribution, is 0. Standard deviation is 1. Then we are going to use calculator to compute this. Now in the calculator, what you'll do is you go to second and then vars and number 3 for inverse normal. Then here you'll type the area. We got 0.995. This is the area to the left of the z-score. You have the mean of 0 because it is a standard normal distribution. Standard deviation 1. If you don't have this one, if you don't have the tail, you can leave it. But I know that my area is on the left, so left is selected. Then paste this in the main screen, okay, and hit enter. You should get this value, 2.5758. So this is equal to 2. You can also write this down, 2.5758. That is the value of this z alpha over 2.
So the rest we have to do by ourselves, right?
Example, in a study of 100 middle school children, the mean number of hours weekly spent playing video game was 15 hours with a standard deviation of 2 hours. We have to find the point estimate for the true mean number of hours weekly that the middle school children spend playing video game. So if you look at this question and try to collect the data that is given here or information that is given here, you will see that in a study of 100 middle school children, so n is given, your sample size, you are studying 100 middle school students, 100, this is your sample. Okay, out of all the middle school students, you are studying only 100 of them. The mean number of hours weekly spent playing video game was 15 hours. That is their mean. Mean of those 100 is 15. And the standard deviation is 2 hours. And standard deviation for the sample is 2 hours. This is the standard deviation for the sample. So I wrote S. Now what we are asked to do is we have to find the point estimate for the true mean number of hours weekly the middle school children spend on playing video games. So when I say the point estimate, this is what it is. There will be a value here in the middle, which is called the point estimate. Point estimate. And this point estimate is used to predict the mean of the population. We don't have any information about population here, but we'll be able to predict the mean of the population later on. So what we do is we have a point in the middle and we say that the population mean, which is also called the true mean, okay? True mean is little bit more than this or little bit less than this. So plus or minus some value. Little bit more than the point estimate or little bit less than the point estimate. So this value in the middle is called the point estimate. And normally, remember this is the key. Normally, the point estimate is the sample mean. Point estimate is the sample mean, or it will be sample proportion. Sample mean or sample proportion. When I say sample mean, it is X bar. And when I say sample proportion, it is P hat. So whenever we are talking about the point estimate in any problem, it is nothing but the sample mean or the sample proportion. So this implies the point estimate in this case is the mean, which is equal to 15 hours. 15 hours is the point estimate. Example. A group of 90 community college students were asked if they plan to transfer to a 4-year university upon completion of the associates in arts degree. So you are studying 90 community college students. So that's your sample size. Let's write this down. Here, n equal to 90. That's your sample size. A group of 90 community college students. That's what you're studying. So when you ask them whether they are going to transfer to 4-year university after completing their associates in arts, 81 of them stated that they plan to transfer to 4-year university. So you can see here, 81 of them, they are willing to transfer. So X equal to 81. X equal to 81. 81 of them, they are transferring to the 4-year university. Now the question is, we have to find the point estimate P hat for the population proportion and also find the Q hat. So here, as we are talking about the proportion, because out of 90 students, you can see 81 of them are transferring. So we can easily find the point estimate. You know, we are talking about the proportion. So the point estimate is a P hat. So here you have point estimate. You can write this down. Point estimate is P hat. Point estimate P hat is 81 out of 90. Okay, it is 81 out of 90. So you can compute that in your calculator. 81 divided by 90, you should get 0.9. You should get 0.9. That is the point estimate. Okay, so point estimate P hat is 0.9. So if you want to predict the true proportion, it will be 0.9 plus something or 0.9 minus something. So that's your point estimate P hat. Once you have P hat, you can easily calculate Q hat, because you know that the Q hat is 1 minus P hat. 1 minus 0.9, or that is 0.1. That's your Q hat. So we got the point estimate 0.9, so that the Q hat is 0.1. Example, a survey of 40 parents found that 80% were worried about their kids spending too much time texting. So here, let's see what is given. We are studying 40 parents. So n equal to 40, that's my sample size. 40 parents, okay, by studying 40 parents, you found that 80% were worried about their kids spending too much time on texting. So this is the proportion, P hat. P hat is equal to 80% or 0.8. So that is your P hat. That's the proportion. So this is about a sample where you have the proportion. Now what you have to do is you have to find the point estimate P hat. So we already have the point estimate P hat. That's equal to 0.8. So let's write that. This implies point estimate p hat is equal to 0.8, because the point estimate is the mean of the sample or the proportion. In this case, it is the proportion, so it is 0.8. Also, after we have p hat, we are asked to find q hat. Now, q hat will be equal to 1 minus p hat. So 1 minus 0.8, which is equal to 0.2. So that is your q hat. Example, from a study conducted of 250 online shoppers. So this is your N, that is your sample size, 250 online shoppers. So make sure you write this down here. N is equal to 250 online shoppers. An online retailer determined that the average amount of time shoppers who shop online at night is 20 minutes. So if they are shopping during the night, the average time they spend on shopping is 20 minutes. So that is the average of the sample. So X bar is equal to 20 minutes. See, our sample size is 250. And when you find the sample mean, it is 20 minutes. The population standard deviation is assumed to be 3 minutes. This is the standard deviation of the population, not the sample. So because it is the population standard deviation, it is sigma equal to 3 minutes. That is the information given to you. Now the question here is you have to find the point estimate for the population mean. We are looking for the point estimate, and you know that the point estimate is the mean or the proportion of the sample. In this case, they have given the mean of the sample. So this is your point estimate. Your point estimate is 20 minutes. So this implies, write this down, point estimate is equal to 20 minutes. Point estimate is 20 minutes in this example. Example, we have to find the T critical or T alpha over 2. In the previous examples, we did Z alpha over 2. Now we have to do T alpha over 2. That means this is the T distribution with N equal to 24 and 98% confidence interval. You have some idea here. When I say 98% confidence interval, you know that the middle area is 98%, 0.98. And because we are talking about T alpha over 2, along the x-axis, you have the T value. This is different from Z distribution or standard normal distribution. This is a T distribution. Okay, this is T distribution. You can write and label on that graph T distribution. T distribution with, okay, one thing you have to check here, whenever you're talking about the T distribution, you look at the value of N. Here, N equal to 24. So if we subtract 1 from 24, 24 minus 1 is 23. So this is with 23 degree of freedom. So we need something called the degree of freedom when we talk about the T distribution. And your degree of freedom is always your N minus 1. Okay, so we have the T distribution with 23 degree of freedom. We have the confidence interval 98%. So middle area is 98%. So label that area. So this area in the middle is 98% or 0.98. So this is 98%. So that these values here, this is T alpha over 2. This is T alpha over 2. And the value on the other side, that is negative T alpha over 2. Because we are calculating this T alpha over 2, we need the entire area to the left of that. So I need the area on the tail. So let's find the area on the tail. Because you have 98% in the middle, The remaining 2% is divided into two parts here. So on each tail, you have 1% area. So this is the 1% area. This area is 1% or 0.01. And this area is also 1% or 0.01. So you have that area. So once you have that area, you can easily find the total area on the left of T alpha over 2. So let's find that. Area to the left of T alpha over 2 is equal to, you can see in this graph now, from here all the way up to here, that's 98%, then plus 1%. So it is 0.98 plus 0.01, 99% or 0.99. Now, because you have this T distribution here, in order to find T alpha over 2, we use the inverse T in our TI-84 calculator. This is how we write. T alpha over 2 is equal to, we have to use inverse of T if it was a standard normal distribution and you're calculating the Z alpha over 2, you used to use inverse normal. But here it's a T distribution, so you have to use inverse T. The first thing that you'll write is, you'll write the area to the left of that. So from here all the way to the left end, the area is 0.99. 0.99. And then you need to write the degree of freedom. N equal to 24. The degree of freedom is 23. Degree of freedom is 23. This is what you have to write. Or in general, you can say this. If you are looking for any T value, you can write this as a formula. This is what you'll do in your calculator. T, any T, it can be T alpha over 2 or simply T, is equal to inverse T. Then you'll use the area to the left of T, area to the left of T, and then you'll write the degree of freedom. This is what you'll do in your TI-84 calculator to get that T value. This is the calculator prompt that you need to remember. Let me share my calculator now. In our TI-84 calculator, we go to second, then vars, and in this case, we go to number 4 because that is your inverse T. Number 4 is inverse T. You have to put the area to the left of T alpha over 2 in this case, and our area was 0.99. We have the degree of freedom. It was 23. And then paste this in the main screen. And we get 2.4999. From calculator, we got this as 2.4999. That's your T alpha over 2. This is 2.4999. If you want to know this, it will be negative 2.4999. So whenever you have the T distribution, you have to use inverse T in your calculator to find the value along the x-axis. You must have the area to the left of that T value. Next example, find T alpha over 2 with n equal to 85. That is your sample size, n equal to 85 for 95% confidence interval. So here we have the 95% confidence interval. So meaning of that is your C is equal to 95% or 0.95. Okay. Your N is equal to 85, meaning of that is your degree of freedom is 85 minus 1, that is 84. So along the x-axis in your normal distribution, in this case, you will have the T values. This is your T distribution. This is T distribution with, you have N equal to 85. So 85 minus 1 is 84 with 84 degrees of freedom. DF is degrees of freedom. Now you have 95% confidence interval. So in the middle, you have the 95% area in the middle. So this is your 95%, 0.95. That is 95%. You can set this so the area clearly. So meaning of that is this value here is T alpha over 2, and this one is negative T alpha over 2. In order to find the value of T alpha over 2, you need the total area to the left of that. So in order to find that, what we do is here in the middle, we have 95% area. So remaining 5% area is divided on the 2 tail. So if you divide the 5 into 2 parts, it will be 2.5%. So this area here is 0.025. And this one here is also 0.025 because these are 2.5% area. So label it like that. Now we have area. Let's find that area to the left of T alpha over 2. If you want to find the total area to the left of T alpha over 2, it is 0.95 plus 0.025, or it is 95% plus 2.5%. So this is equal to 0.95 plus 0.025. 95% plus 2.5% is 97.5%, or 0.975. If we add these two numbers, it will be 0.975. That is the total area to the left of this T alpha over 2. Now, in order to find the value of T alpha over 2, because we are talking about the T distribution, we use inverse T. Inverse T, we write the area first, area to the left of this one. The total area is 0.975, 0.975. And the degree of freedom here we have 84. So degree of freedom is 84. Now we are going to use TI-84 calculator to get this value. In TI-84 calculator, we go to second, then vars, and number 4. Here you'll write your area, which is 0.975. Here we'll enter our degree of freedom. In this case, we have 84. We go here and paste this and hit enter. You should get 1.9886. So from the calculator, we got 1.9886. That is your T alpha over 2. T alpha over 2 is 1.9886. If you are asked to find this value, it will be negative of that.